Today we're going to observe magnetic field for a permanent magnet and for a couple of electromagnetic configurations. First off, you can see here I have a magnet sitting on this table here. This magnetic field sensor is nothing but a little magnet, so we can observe how the magnetic field changes as we move this sensor around. You can see that conventionally North Pole is red, South Pole is in blue. Excuse me. So with this sensor, the little magnet, the red is always attracted toward the South Pole. It points in the direction of the magnetic field lines. See, magnetic field points away from the red, it points away from the North Pole. Sometimes I have to play with the sensor a little bit to get it to behave. Comes away from the North Pole, comes around, points toward the South Pole. If I hold it below here, you can see we come away, we're pointing away from this. Alongside the magnet, it's pointing more or less straight ahead. Then we come around the magnetic field. The red is pointed toward the South Pole. Great, so that's a permanent magnet. Now we can look at the magnetic field from a single wire. That tends to be kind of wimpy, a little hard to measure with the sensor. What I'm going to do, I'm going to soup this up. We have a coil here, this Pasco equipment, a 200 turn field coil. So there's a lot of turns here. With those 200 turns, we're going to get a nice strong magnetic field. We're also going to see, we're going to look at the direction of the magnetic field. We'll see how the right-hand rule applies in this case. You can see down here the direction of the current flow. It's going to come in from the red, come out of this 850 universal interface. It's going to come in, come around the loop in this whole direction. So anywhere along here, if I use this right-hand rule, my thumb points along the coil. The magnetic field is on the inside of the coil. It's going to be curling in. My fingers are coming this way. On the outside, it wraps around and points back the other direction. So let's see if that indeed happens. I have here a Pasco capstone interface. I'm going to turn on the voltage source. We're going to get some current flow. So let's look first. I'll bring the sensor up. I'm just going to hold it nearby here. We can see our magnetic field sensor is not doing a whole lot right now. If I move it around the coil, it's just sitting pointing in this constant direction. If I now come on and turn on the coil, get some current flow through it. See, we have current flowing. Now, the magnetic field sensor has woken up and says, oh, here in the middle, I've got current. I have magnetic field. It points right in the center. If I wrap up and around this thing, as I go around the coil, you can see it's making a nice loop. It's all the way around. Yeah, it's flipping around, making a lovely loop. Cool. Okay. We can also look at the strength of the magnetic field. I'm going to try to get this in here where you can see both these. I want to see the strength of the magnetic field and the magnetic field sensor. I'm going to bring this around. We can see both. You can see on the top, we're looking at the strength of the magnetic field in Tesla. So it's reading a rather small amount. I'm going to zero it out right now. I'm going to zero it. It's saying that it's reading something about 10 to minus 6 Tesla. That's a very small magnetic field. If I bring the sensor now close to the field, you can see it's coming up now. I'm seeing a nice steady number about 8 times 10 to the minus 4 Tesla. Very cool. And you can see I've got it sitting right in the center here. As I get closer to the center of the coil, the magnetic field is going up. If I push all the way through, then we see the magnetic field is starting to drop down again. Yes, our strongest magnetic field is right there in the center, right at the center of the coil. If I reverse this is a Hall effect probe, by the way. It's kind of hard to see in the picture here, but that Hall effect that we talked about last time, there's two little sensors right here in the end that'll measure the strength of the magnetic field. If I come around the opposite direction, now I'm seeing this is an axial field sensor. I'm pointing this way, it says now I'm getting a positive magnetic field. So you can use this probe to measure the strength of the magnetic field. It gets stronger if I go toward the edge of the coil. Let's try this from the side here, we can see both. If I move the sensor closer to the edge of the coil, it's going to increase. I'm getting a larger and larger magnetic field. Eventually it maxes out, it zeroes out here. So the magnetic field, see out at a distance here, it gets weaker as I go further away from the coil, coming right in toward the center of the coil to reach a maximum value. If I get closer to the coil itself, the magnetic field gets stronger. That's the formula for the strength of the magnetic field. Remember, the closer you are to the coil, the stronger it is. I can go outside here. I also see magnetic field. Notice it's changed direction. It's flipped sign. If I get closer to the coil, the magnetic field is stronger. If I go further away, it gets weaker. Eventually, it's just dropping down to where it's basically lost at zero. All right, so that gives you a general sense of how the magnetic field behaves. One more observation. I have set the field sensor so it's sitting on top of a box. It is just about in the center of the coil. I wanted to do that so I can be hands-free here. We're going to observe the magnetic field again. I'm going to turn on the current flow, and you'll see it. There's a certain strength of magnetic field right now. We're seeing about 7 times 10 to the minus 4 Tesla with this 0.6 amps of current. If we change the voltage, if I drop the voltage down, see current comes down, the magnetic field goes down too. It's pretty much linear with the magnetic field. If I drop, with the current, I drop to the voltage, current comes down, drop the voltage again, current comes down, and you can see the magnetic field dropping. If I bring the voltage up, again, notice the magnetic field increases. I can run this up to about 1 amp coming out of the sensor, so we'll run it up a little bit higher. And there, I've actually maxed out the sensor at that point. That's the highest value that it will read. Okay, so there you see the sensitivity of magnetic field to current flow. We'll observe this in more detail in the lab that will have you do next week.